I'm going to demonstrate how to set up and use the oscilloscope that's built into Triggy. Of course, the oscilloscope input or output cable rather is this USB-B type at the top, marked oscilloscope. So I've connected that cable there. This is the other end of it. Before I plug that in, I just want to show you a process that you need to go through in order to get the oscilloscope to be recognized. Once you plug it in, there's going to be a tone, and you assume that because this screen comes up, that everything is as it needs to be. But in fact, for the oscilloscope software, TracerDAQ, this little icon, to be able to recognize the oscilloscope, it needs to be in a short list of recognized devices. So to make that happen, we need to start something called InstaCal. And once I load InstaCal, it should recognize the device I have installed, sort of like by its serial number. And it says that it's been detected, and then I'm going to say OK. And now I have this one universal serial bus device in InstaCal. And that's all you need in order for this to work. Just make sure that that appears there, and then close. And then we're going to use the TracerDAQ, which is the oscilloscope software. Mine is TracerDAQ Pro. If you don't have the paid upgrade, then you'll have the free version called TracerDAQ. So I'm using the second option here called Oscilloscope. I'll click Run. This measurement panel comes up for me, but I'm going to close that, and then I'll maximize the screen. So we have the oscilloscope software here, and I'm just going to increase the time base to 20 milliseconds. That's per division. And I want to show you a few things about setting up to use the oscilloscope. So, of course, I have a signal source. It's audio coming from my PC over here into channel number 1, which is configured for audio. And you can see the little LED flickering each time the sound plays out. This is, again, that short click, and it's producing a little bit of a response, just a short TTL output. In order for the oscilloscope software to capture signals from the device, we have to tell it which channels to send to which DAQ inputs. If I select Edit DAQ Hardware Settings, in my TracerDAQ Pro, I have 4 channels here. Your unpaid version may have just 2 channels. That's fine. You just need to be able to assign each of those channels or rather, you need to select from the available DAQ channels among those 2. So for mine, I have selected DAQ channels 0 and 1. I'm going to ignore the next 2 for the moment, but 0 and 1 are the first 2 DAQ channels of the DAQ card, which is in the top of here. That's not necessarily the same thing as Triggy channels, and I'll explain why. So Triggy has 8 channels, each of which has an analog signal, for example, the audio, and a digital signal, which is the TTL output that's coming when a sound is detected. So you have 8 channels times 2 signals, that's 16. Plus on the back there's an auxiliary input, so that's actually 24 channels. But the DAQ only has 8 channels, and for the oscilloscope you're only really going to be able to use 2 of those unless you get the paid version of the software. So in order to select which channels will go to those available DAQs, you can use the right button, the right arrow button, and go over to Scope/USB, and then go down to the Oscilloscope Channel Select menu. And in this menu, it's going to walk you through the process of selecting which Triggy channels will go to which DAQ channels. So it first asks me whether what I want is an analog or a digital channel, and I'll say digital. And which DAQ do I want to assign it to? I'll say 0 because I've already selected 0 and 1 there. And which of the channels do I want there? It's already reading 2, but I actually want 1. So I'm going to select 1, set that as default, so the next time I turn it on, it will be set the same way. And then I'll go through that process again, except this time I'm selecting an analog channel. That's the audio that comes from the sound card. And I'm going to send that to DAQ number 1. So I've assigned to DAQ 0 the digital channel, and for DAQ 1 the analog channel coming from channel 1. Because remember again, the audio is on channel 1 and it has 2 forms, analog and digital. So first question it asks is which of those I want, and then from which channel to go to which DAQ channel. All right, so I've selected those 2 channels just for the sake of demonstration. Let's start with that. So we have 2 channels assigned to the TracerDAQ. Just to reconfirm, I'll go Edit, Hardware Settings, and you can see that DAQ 0 and DAQ 1 are on the first 2 available channels. Ignore the rest. This symbol, the E, is where you enable or disable a channel. So I'm just going to turn off 2 and 3. DAQs 0 and 1 are on. And you can see they have a scale. Each of them has an independent scale. And then there's the time base here. Another feature is this trigger threshold. That's important to note. We'll use that to determine where on the signal to catch events that are exceeding the threshold. And then when it triggers, you'll see the signal in this window with a vertical cursor that we can move in order to move the signal to the left or to the right of the window. So I'll just hit start, this right, it's like a play button, right facing arrow. And you'll see on the top, we have channel 0, which is the digital output that is being produced by Triggy in response to this analog input. So our time base is 20. Maybe that's a little too long. I'm going to reduce it to 10. And we can see a little more clearly the relationship between the audio and the TTL output. If I drag this up, by clicking and dragging on the triangle, then you can see the relationship, the temporal relationship between them more clearly. If I want to zoom in on that more, just reduce the time base further. And you can see that with that first departure from baseline, we're triggering faithfully. If I want to increase the size of the audio signal, I can decrease this range. That increases the effective size of the signal. If I wanted to increase or decrease the trigger channel signal, I can do it here. So that's the TTL output. You'll notice that the trigger is set with this solid T and a rising edge. So the signal on the trigger channel, the digital channel, is a rising signal. If it were inverted, for example, if it were a signal coming from an analog sensor that was going downward, we could tell this to trigger on the falling edge. If I do that here, you'll see that here we're triggering on the falling edge of channel number 0, which is the TTL output. That's not terribly helpful. We want to know about the rising edge, so I'm going to switch that back. So we enable them and we trigger on them by selecting this. If I select T here, you'll see that I'm now triggering on channel 1. And if I drag this down just above, Now I'm triggering on channel 1. You'll notice that it's not always in the same place because it's bouncing around since it's detecting multiple events that meet the criteria. That's why I had chosen to trigger on channel 0, because it's a single event per detection. Whereas on the audio, you have multiple events. So there are a lot more options, but let's just look at how the cursor works. So if I drag this to the left, I can move my signal to the left or to the right. If I put it where I want it and I want to measure it, I have these two vertical cursors. I can put one, for example, I don't know if I want to put it here, and another one at what I believe to be the end of the audio signal, about there. It gives me a delta, so 12.1 milliseconds. It gives you a lot of other parameters as well, but measuring time differences is one common use of the cursors. So you may have noticed before when I was triggering with this setting that it would stop. And that's because this is what's called single mode. So if I click this, it'll trigger once and then stop. So if you want to measure just one time, that's what you do. But if you want to keep measuring each time the criteria are met, select the solid colored T, and that will just keep updating. You can see it's armed reading and then armed and then reading. If you get the paid version, you'll have 4 channels, so you could measure more signals. And of course, these signals can be digital or analog copies of the signals on these channels, or they could be coming from an external input on the back of the device. And to select which signal goes to which jack, you use the last menu item, Scope USB Oscilloscope Channel Select.